Hello and welcome to this video. In this video, we will look into the topic similarity. Two objects are said to be similar if they have the same shape and their corresponding sides are in proportion. Whereas two objects are said to be congruent if they are identical in shape and size. In this video, we will concentrate more on similarity of objects. So similar objects will have same shape and their corresponding sides are in proportion. So one object is an enlargement of the other. So how to prove two objects are similar? Two rectangles. If you consider this side, this is the corresponding side of the other object. That is the other rectangle. To show that two non-triangle objects are similar, you need to show that their corresponding sides are in proportion. Okay. So for this side, the corresponding side is this one. Okay. We have to prove these sides are in proportion. Okay. Suppose if I mark this as L1, this is L2. So L1 over L2 will be, take it as K. Then this side and this side in this triangle should also have the same ratio. Suppose if I mark this as D1 and this is D2, so D1 over D2 will also should be equal to K. Okay. This K is known as the scale factor. So what is scale factor? Dividing the length of one side of the object by the length of the same side on the other object is a scale factor. If the scale factor is same for all the corresponding sides, then the shapes are similar. Let's look into this example. Determine whether the shapes in each pair of the shapes are similar or not. Consider the first example. Okay, let's find out the ratio of the sides 30 and 12. If you divide the numerator and denominator by 6, you will get 5 over 2. And now take 20 and 8. Divide the numerator and the denominator by 4. You get 5 over 2. So in both the cases, the ratios are same. That is, the scaling factor is same. So these two shapes are similar. Consider this shape. Let's take 12 and 18, the ratio, and 2.5 over 5, 10 over 15, and 8 over 12. On simplification, it will give 2 over 3. The ratio is 2 over 3, and here it is 1 over 2, and this is 2 over 3, and here also 2 over 3. Okay, but this ratio is different, so these two shapes are not similar. Now let's consider this diagram. The ratios are 51 over 6, which is equal to 17 over 2. That is 8.5. So this ratio will be 34 divided by 4, which is equal to 17 over 2. Again, this is also equal to 8.5. The ratios are same, so this is a similar triangles. Okay, now consider this. So in this case, the sides are not given, but the angles are given, and this is 75, and here also it's 75, and this is 65, here also same, 40, 40. So if all the angles of two objects are equal, then they are similar. Okay. Whenever you need to check the similarity, first you need to check whether all the angles of two objects are equal, then they are similar. Otherwise, you need to find the ratio of the corresponding side equal. Okay. Then also the objects are said to be similar. So these two triangles are now similar. True angles are same, we may need to use angle properties. Look for a isosceles triangle, vertically opposite angles, and angles on parallel lines. Consider this isosceles triangle. We know in isosceles triangles, these two sides are equal, okay, and these two angles are equal, okay, and this line AD intersects the line BC at the midpoint. So this side and this side also will be equal, and this angle also equal. Okay, that is perpendicular. So in triangle ABD, the angle at B we know, the angle at D also we know it is 90 degree. Then we can calculate angle at A. Okay. Similarly, in triangle ADC also we can calculate this angle. Okay. So all the angles are equal in the triangle ABD and ADC. Okay. The triangle ABD and ADC are similar. Okay. And whenever you come across two lines crossing each other, we can check for this property. Vertically opposite angles are equal. Okay. When a line passes through two parallel lines, it makes angles with the parallel lines. The corresponding angles are equal in that case. So you may use this angle property also to prove the similarity of objects. Or you can look for alternate angles are equal property. Similarly, you can use the property allied angles add up to 180 degree. Okay. Now let's consider this example. Explain why triangle ABC is similar to triangle PQR. So first, let's find out the third angle in this case. In a triangle, the sum of all three angles will be equal to 180 degree. So angle at C will be equal to 180 minus 78 minus 37, and which is equal to 65. So this is 65. And this angle is angle at AP is equal to 180 minus 78 minus 65, which is equal to 37. Okay, so 78 is here and 37 is also there. 65 is also there. So all three angles are there. Okay. If all the angles of two objects are equal, then they are similar. So this is a similar triangles. Now look at this example. In the diagram, AB is parallel to CD. AD and BC intersect at X. Show that the triangle ABX is similar to triangle DCX. Okay. So let's find out the angles it makes because two parallel lines are given. AB and CD are parallel. Vertically opposite angles are equal, so the angle at here and here are same. And the alternate angles are equal, so angle at B will be same as angle at C. Similarly, angle at A will be same as angle at D. So all the three angles are same, so it is similar. So now let us look at this example. In the diagram, AB is equal to AC and BN equal to NC. Complete the statement using a mathematical term. And this is an isosceles triangle. So this angle and this angle will be same, and this will be 90° because N is the midpoint. So here also it will be 90. Two angles in a triangle. So then we can calculate the third angle. So we know all the three angles of ABN. Then in ANC also we can calculate this angle, which will be same as this angle. So these two angles are same. Okay. So all the three angles are same. So triangle ABN is similar to triangle ACN. Similarly, you can try this example by yourself. In triangle PQR, M lies on QR and S lies on PR. Explain giving reason why triangle PMR is similar to triangle MSR. So just find out the angles and prove the two triangles are similar. Okay. Share your answer in the comment section. Finding the unknown length. When two triangles are given as similar, then we can find out the unknown side of one triangle or other object, unknown side of another object. Okay. So here two shapes are given. Shape ABC is similar to shape PQRS. Work out the value of A. Okay. When two shapes are similar, their corresponding sides are in a ratio. Same ratio for all the sides. So 5.5 divided by 7.7 will have the same ratio as A over 9.8. That is, it will have the same scaling factor. Now make A as the subject. 5.5 multiplied by 9.8 divided by 7.7. On simplifying, this gives 7. And this example, uh, triangle CBA and CED are similar. AB is parallel to DE. AB is 9 centimeter, BE is 4.8 centimeter, EC is 6, and ED is K. Work out the value of K. So this is triangle CBE. CBE. So this is 9 and this will be 10.8. And CED. This is K. This is 6. Okay. So the two triangles are similar. So the corresponding sides will be of the same ratio. That is, the scaling factor will be same. So 9 over K is equal to 10.8 over 6. So K is equal to 9 multiplied by 6 divided by 10.8, which is equal to 5. You can try this example. Two triangles are mathematically similar. You need to find the side. You mark this as X and find the value of BC. Okay? Try to do this and share your answer in the comment section. This is 2. Next topic is similar areas. When two objects are similar, then the area of the first shape divided by area of the second shape will be equal to the scaling factor, the whole square. Okay, what is the scaling factor? The side of one object divided by the corresponding side of the another object. Area of first object divided by area of the second object will be equal to L1 divided by L2, the whole square, or scaling factor square. If you are representing scaling factor by the letter K, you can write K square. The diagram shows two mathematically similar triangles T and U. Two corresponding side lengths are 3 and 12 centimeter. The area of the triangle T is 5 centimeter. Find the area of the triangle U. So we need to find area of this triangle. Okay. So we know area of the first triangle is 5 divided by area of the second triangle. Let's write this as area equal to the ratios of their lengths, 3 over 12, the whole square. Now make area as the subject. Area is equal to 5 divided by 3 over 12, the whole square. 3 over 12 will be simplified into 1 over 4, the whole square, which is 1 over 16. So 16 multiplied by 5. 80 centimeter square. Similar to that one, here also you need to find the area of the triangle. When two triangles are given and the area of the one triangle is given as 25, and their corresponding sides are given. Okay, you need to find the area of the triangle ABC. Try this also. Share your answer in the comment section. Next, similar volume. When two triangles, when two objects are mathematically similar, the ratio of their volume will be equal to the ratio of their lengths, the whole cube. That is, volume of first object divided by volume of the second object will be equal to the ratio L1 divided by L2, the whole cube. You can write it as scaling factor whole cube, or if you are representing it by letter K, write it as K cube. Okay, so two solids are mathematically similar. The smaller object, the smaller solid has height 2 centimeter and volume 32 centimeter cube. The larger solid has volume 780 centimeter cube. Calculate the height of the larger solid. So what is the volume here? 32 divided by 780, which is equal to, smaller solid has a height 2, so 2 divided by, we need to find the height of the largest solid, so I will use the letter H here, the whole cube. Okay, now make H as the subject, so H cube will be equal to 2 cube multiplied by 780 divided by 32. 2 cube is 8. If you divide by the numerator and denominator by 8, this will be 1 and this is 4. Now cancel these two number with 4, so you get 195. So H cube is 195. What is H? Cube root of 195. So H, we are getting it as 5.798. I'll round it up to one decimal place. So H is 5.8. Similar to this one, try this question. Calculate the volume of the smaller prism. This volume you need to find. So here two triangles are mathematically similar. The volume of the larger prism is 320. Find out the volume of the smaller prism. So these two are the corresponding sides. Find out the scaling factor, then you can calculate the volume of the smaller prism. Okay, try this also. Share your answer in the comment section. And this one is a little bit challenging one. Let's do this one. Two bottles and their labels are mathematically similar. The smaller bottle contains 0.512 liters of water and has a label with area 96 centimeter square. The larger bottle contains 1 liter of water. Calculate the area of the larger label. Okay. So volume of the two bottles are given and area of one label is given, and we need to find the area of the larger label, another bottle. Okay. For smaller, volume is 0.512 and area is 96, and for larger the volume is given as 1 and we need to find area. So no length is given here, so we know volume, 0.512 of the first object divided by volume of the second object is nothing but the scaling factor, the whole cube. So let's write 0.512 divided by 1 equal to, I'll use the letter K to represent the scaling factor whole cube. So what is K? Cube root of 0.512, which is equal to 0.8. So now we know K. By using this scaling factor, we are going to find the area of the larger label. Okay. So for that, we will use the ratio 96 divided by area of the larger volume equal to the scaling factor, the whole square. Okay. Now make area as the subject. Area is equal to 96 divided by 0.8 the whole square. Which is 150. So the area is 150 of the larger label. So two containers are mathematically similar. The surface area of the larger container is 226 centimeters square and the surface area of the smaller container is 94 centimeters square. The volume of the larger container is 680. Find the volume of the smaller container. Okay. In this case, the area of the two containers are given and volume of the larger container is given, and you have to find the volume of the smaller container. Okay, find out the scaling factor first. From that you can calculate the volume of a smaller container. Use the area of the two container to calculate the scaling factor. By using that scaling factor you can calculate the volume of a smaller container. Okay, try this also. Share your answer in the comment section.